Mercado math, it's time to do some math. Let's Merca do it. System of equations. This is one of those things a lot of people have heard of before. Some of you have done it. It is a skill that you use a lot of. It is a skill that if you actually know how to use it, you use it almost every day in some sense. But like I said, it's basically a comparison if you want to kind of figure that. Last time I showed you how it works with lines, with substitution. And like I said, we did substitution method. Today is the elimination method. This is as easy as an elimination method gets. All you have to think about when you think about the elimination method is opposites. The reason you want opposites is because opposites cancel. So when I look at this problem, you're trying to find two numbers when you add them up to get 5, and when you subtract you get -9. What you want to think about is opposites. And right here, there are my opposites. Positive y, negative y. That's what opposites are. What's the opposite of 2? -2. What's the opposite of -7? +7. That's what you want. You want opposites. So, the moment you realize you see opposites, all you're doing is combining this. This is also sometimes called the combination method. I always call it the elimination method. If you Google combination method, it's the elimination method. They're interchangeable. It's whatever the hell the book wants to call it at the time. I grew up calling it the elimination. So what do I mean you combine them? You're literally going to add them. X plus x is 2x. Now the whole point of this, it's called the elimination method, is to eliminate crap. That's why you want the opposites, because when you add opposites, you get 0. They basically cancel out. Equals equals. 5 minus 9 is -4. And now you have this little baby equation. 2x equals -4. That's one step to solve. Divide by 2, and you get x equals -2. And you're done. If you look at the amount of work I did, there's not a lot of work up here. And you're essentially done. However, you found x. Don't forget, once you find x, you got to find y. How do you find y? You plug it into one of these. You can plug it into whichever one you want. I'm going to plug it into that top one. So it's x. I just found out x is -2. Plus y equals 5. To solve that, to get y by itself, we are going to add 2. Add 2. And I have y equals 7. Remember, if you want to check your work, the beauty of this is you can check your work every single time. There's not a scenario where you don't know if you got the answer right. If you plug it in, you should get -9 for this. -2, you can plug it in, -2 minus 7. Yeah, that's -9. I feel good about this. You also could have done this using the substitution method. If you remember how substitution works, you get the x or y by itself, and these are pretty easy to do. However, this is definitely the fastest way to do this problem. This problem, elimination, you're done. If you break down how many steps I did, x plus x divided by 2, added 2. The entire problem is 3 steps of work. All right? Now let's add a step. Okay, so once again, the name of the game is make opposite. If you have them, great. If you don't, you make them. I look at this. I don't have any opposites. Remember, the opposite of a number is the different sign of that number. The opposite sign. It's, they didn't want to make it sound too easy. So when I look at this, 3, 3, those are not opposites. They're literally the same number, so they can't be opposites. If you try to combine these, if you add them up, 3x plus 3x is 6x. They do not cancel, so you can't add them. 2 and -5, obviously those aren't going to cancel. So what do? Well, if you don't have opposites, you make opposites. What's the opposite of 3? -3. So that's what we want to do. We want to make a -3. You have to pick which one you want to make -3. You can pick the top one or the bottom one. It's your choice. There is no wrong answer. There's sometimes a slightly easier choice, but there is no wrong choice. So I'm going to go with the top one. I'm going to make the top one negative 3. How the hell do you make it negative 3? I'm going to multiply it by negative 1. When you multiply it by negative 1, you will distribute the negative 1 to every term. And then once you do that, you will get a brand new equation. I will now get the equation negative 3x minus 2y equals, don't forget this last one. People always forget that last one, positive 14. These are now the two equations I will combine. Once again, it's sometimes called the combination method. So you kind of ignore the top one that you had, and I'm going to focus on these two. So I'm going to combine them, and now that I have opposites, 3, negative 3, when I combine the x's, they cancel. Negative 5y minus 2y is a negative 7y equals 14 minus 7 is 7. A little more work to get the answer. Divide by negative 7. Divide by negative 7. And I get y equals negative 1. Now that I have y, don't forget you need to get x. The x should be the easy part. How do you get x? You got to plug it into one of the equations. I now have 3 different equations. I'm going to probably plug it into one of the originals. Once again, there's no wrong one to plug it into. There's sometimes an easier one, but there is no wrong choice here. I think a lot of you would probably plug it into the top one because you like that positive. So we have a 3x, I don't know what the hell x is, that's what I'm looking for, plus 2y, I just found out y is negative 1, equals negative 14. Once you're there, I'm going to get a little multiplication going. 3x minus 2 equals negative 14. And now you have a regular old two-step to solve. To get x alone, I'm going to get rid of that minus 2 by doing plus 2 plus 2. Remember, get rid of what's furthest away but on the same side. That leaves me with a 3x equals different sign, subtract, keep the more dominant sign, negative 12. And now one step left to get the x. Divide by 3, divide by 3. X equals negative 4. I found my x. I found my y a while ago. There's x, there's y. Keep in mind, you will often see this written as a coordinate. Even though I found y first, remember the first thing that goes in the coordinate is the x coordinate, then the y coordinate. You are still finding the point where these lines intersect. These are two lines. They're written in standard form. They're regular old linear equations. They're in standard form. You're just finding out where they meet, where they cross. All right? Let's make a harder one. And even though it's harder, it's really just a matter of, do you know your times tables a little bit? So now this is more realistic to the sort of problems you need to be able to do. This is still not what I would consider a very hard one, but to be honest, this is very normal. If you can do this one, you can do the harder ones. So what makes this difficult is not only are there no opposites, there's not even the same number anywhere. You have 3, 4, and 5, 10. Now the name of the game is opposites, and you don't have any. So what do? You make them. Just like in the last problem, we multiplied by negative 1 to make them. I have to make one of these sets opposites, either the x's or the y's. It's your choice. This is where, if you're very good at math, you instantly kind of know what the better solution is. But if you're just okay at math, you can still figure this out. So I'm going to show you the long way to do this, even though some of you might already have an idea. Now this is what you should be doing in your head. I'm just going to write it out. First, I'm going to look at this 3 and 4. 3 and 4. And I have to decide, all right, what number can 3 and 4 both become? Basically, you're looking for the LCM, the least common multiple. You do that all the time when you add and subtract fractions with the least common denominator. So 3 and 4 can turn into 12. So that means I would need a 12 and negative 12. I can make a 12 and a negative 12 out of this. That would be my opposites. I also have a 5 and 10. I can play around with 5 and 10. And then you play the same game. What can 5 and 10 turn into? What's the LCM? Well, the LCM of 5 and 10 is 10 and negative 10. Now, this is the better choice, and the reason it's a better choice, look what you already have. I already have a negative 10, which means I would only have to change this one. In order to get 12 and negative 12, I would have to change both equations. With this, I only have to change one. Now, keep in mind, there's other choices here. You can change 12 and negative 12. You'll get the same answer as me. Hell, you can even make this 48 and negative 48. You will get the same answer. Huge numbers, but you will still get the same answer. With a calculator, it really doesn't matter. But for our purposes, 10 and negative 10 is the better choice, so that's what I'm going to make. I want a 10 and a negative 10. So, I already have negative 10. So now I need to make this top one, this top equation, into 10. How does 5 become 10? Times 2. Everything gets multiplied by 2. 2 times 3x is 6x. 2 times 5y is a positive 10y. And if you did this right, you already see it. You have your opposites. They're going to go. Equals 2 times negative 19 is a negative 18. Once you're there, you can combine the one you didn't change and the one you did. Remember, you kind of got rid of this one. These are your two equations you are combining. We combine them. 4x plus 6x, that's 10x. The whole point of this, the whole reason you did this, is to get rid of that 10 and negative 10. Gone. Remember, those were the opposites I was making. And 38 minus 18, that ain't so bad. That's just 20. Now that you have this, one step, divide by 10, divide by 10, you get x equals 2. And once again, you have x, you need to find y. Now you can plug it into whichever one you want. I'm going to plug it into, just for the hell of it, I want to plug it into this bottom one. 4x, I just found out x is 2, minus 10y, equals 38. Be careful. Some people have a tendency to start writing one equation and then move over to the next one. I might get something equals negative 9 here. Just make sure you follow along to the same one. This is an 8 minus 10y equals 38. Minus 8 minus 8. Negative 10y equals 30. Divide by negative 10. Divide by negative 10. Y equals negative 3. I have my x, I have my y. Now, once again, maybe you didn't feel good about this question. Maybe you're like, oh crap, that didn't feel right, and you have a little extra time on a test or quiz. Remember, you can check your answers. You will know if you are correct or not. So I just want to check it. I want to see, all right, did I get this right? I have a little extra time. 3x plus 5y. 3x is 2, so that becomes a 6. Plus 5y. Negative 15. And I'm like, does that equal negative 9? Yes, it does. All right, so that works in the first one. Just because you check one, you need them to work in both. Remember, you got to check them both if you want to make sure. 4 times x, x is 2, so that's 8. Minus 10y, 10 times negative 3. Negative, that becomes plus 30. Negative 10 times negative 3 is a positive 30. 8 plus 30, 30, yep, 38. Now I feel a little better. I checked my work. I'm like, all right, this is fine. And keep in mind, for multiple choice, they ask you what the solution is. You can literally, instead of having to do this crap, you can plug it in. There's a lot of little shortcuts on SATs and stuff where multiple choice questions, there's a lot of loopholes for. But this is it. And like I said, you could have done 12, negative 12. You could have made this 100 and negative 100. It doesn't matter. You technically have infinite ways to do this problem. This was just the easiest. Now let's do what's considered a hard problem. The name of the game, opposites. You don't have them. If you don't have them, you make them. These are both in standard form. They're lined up perfectly. I want something to cancel out. I don't have it. So I'm going to make it happen. Now, this is the mental math you should be doing. You should very quickly be able to look at 6 and 4 and come up with an LCM and 2 and 3. However, if you can't, you can line it up. You can think about it. Take a little bit of time. There's nothing wrong with taking a little bit of time. Some people, it's a little better, instead of trying to think of the best choice, just think about the choice you come up with first. It's not always about finding the easiest solution. If you get a solution, that's just as good. So this is the mental math. I'm playing 6 and 4. 6 and 4. The way you do LCM, times tables of 6 and 4. You find the match. 6, 12, 18, and once again, I already said it, 12. This can become 12 and negative 12. 2 and 3. What can 2 and 3 both become? Like I said, you kind of play that game. 2 and 3. 2 and 3 can become 6 and negative 6. Those are the opposites I want to make. Some people might try to make 6 and 4 24. That's not wrong. If you make it 24 and negative 24, you will get the same answer. It's just all the numbers are going to be a little bigger. You're going to just make life a little harder for yourself if you don't have a calculator. These are my easiest choices. And now you have to pick one. And this is where, like I said, choice is going to matter. Neither of them is easier than the other. These are both the exact same amount of work. I can tell you right now, there is no better choice here. There's whatever the hell you feel like. So some people might want to pick the 12 negative 12. Some people might want to pick the 6 negative 6. I know what I want to pick. And that's just 6 and negative 6. That's what I want to go with. If you wanted to do 12 negative 12, you can. But I'm going to go 6 negative 6. So when I go 6 negative 6, I need to make one of these 6 and one of these negative 6. The way I always did this when I was younger, I would try to make them both 6 and then figure out which one I can make negative. So how does 2 become 6? Times 3. How does 3 become 6? Times 2. And if you notice here what's kind of nice, you already have that positive and negative. So 3 times 2 is already 6. And 2 times negative 3 gives me that negative 6. So now that I have this, we go, all right, let's get my 2 brand new equations, because I'm going to get 2 new ones. 3 times 6x is a 18x. 3 times 2y is a 6y. 3 times negative 4 is a negative 12. Down here, 2 times 4x is 8x. 2 times negative 3 is a negative 6y. That's the whole reason we did this. We want to cross these out. 2 times negative 20 is a negative 40. These are the equations I am going to combine, and let's see what we get. 18x plus 8x. 18 plus 18 would be a 26x. And you're like, oh crap, I don't know my 26 times tables. It's not going to be that bad, trust me. The whole reason you did this, 6y minus 6y, gone. Equals negative, same sign, we add, keep the sign, negative 52. Now you really don't have to know your negative, your 26 times tables to kind of see the connection here. 52 divided by 26 is 2. You get a negative 2. X equals negative 2. And now that you have x, you can plug it in and solve for y. To plug it in to solve for y, we go, all right. You pick whichever one you want. I'm going to plug it into that top one. Let's get those out of the way. 4x. Oh no, what did I say? The top one, right? 6 times x. X is negative 2. Plus 2y equals negative 4. Once you're there, you have a negative 12 plus 2y equals negative 4. I don't know why the hell I started this so low. That's just poor decision making. Plus 12 plus 12. You have a 2y equals 12 minus 4 is 8. Divide by 2, and you get y equals 4. That's it. That's your answer. Nothing special about it. Nothing crazy. If you, once again, break down the work you did, the main step, getting this LCM is the main step. If you can get an LCM, you're set. It's just about making those opposites. Once you get those opposites, once you get these 2 equations, it's quick. If you can get here, things go very quickly. It's just a matter of, can you get there? We're going to do one special case to remind you about that, and that's kind of it. We're going to do one more special case. Special case, all you got to really know, is you're doing the same thing. 2, 6, 5, 15, play the game. What can they turn into? This is all the kind of crap I would love for you to do in your head. 2 and 6 can turn into 6 and -6. A lot of people for this would get 12 and -12, and that's not wrong. Just remember, that's just going to make your numbers a little bigger. It's going to scale it up a little bit. That's the LCM, though, and I will always use the least common multiple. There are more multiples, though. It's the least common multiple, but there are infinite common multiples. 5, 15 can turn into 15, -15. I'm going to go with this 6, -6. They're smaller, so that's what I'm going to go with. Now, what's nice is I already have the 6. So 6 is done. I have to make this one -6. How does 2 become 6 times 3? But I don't need 6. I already have a 6. I need a -6, so I'm going to make this a -3. And now that gives me my new equation, -6x, remember we're distributing, -15y equals -24. And if you notice what happens here, everything kind of has these opposites. The 6x and 6x, this is the whole reason I did this, cancel out. Great. Then this cancels out. Then these cancel out. And the problem here is people forget what that means. When you cancel things out, there's usually a number there, so you don't have to write it. In this case, 6 minus 6, even though we cancel out, it actually equals 0. It's just we don't always have to write 0. Equals 24 minus 24. Even though we would cancel that out, there's nothing else there, so you need the number to hold its place. What number's there? 0, and this is what I get. 0 equals 0. If you remember what this means, great. If you don't, there's a video on special cases. 0 equals 0, you go, yeah, 0 does equal 0. It makes a lot of sense. The reason it makes a lot of sense, there's a lot of answers here. There are infinite solutions. Okay, remember, it's not all real numbers. This is infinite solutions. If you remember what that means from the special case video, it means the lines are literally on top of each other. Remember, you're trying to find where they intersect. What this means is there's a line, and there's a second line, and it's literally right on top of it, so it intersects in every single point. It is literally on top of it, so every point intersects on here. That is infinite solutions. And if you look at the original equations I gave you, you might notice this equation is the same as this one. It's just this one is 3 times bigger. It's scaled up by 3. They're the same equations, just this one was 3 times, this one's 3 times bigger. That's what that looks like. Infinite solutions, remember, it's the same number equals it. It makes a lot of sense. No solution, parallel lines, it's when you get crap that makes no sense, like 0 equals 7. That doesn't make sense. Just remember, like I said, this is one of those things that when you get it, people kind of screw up because they forget what happens when you cross out a number. You get used to crossing things out, you forget it actually means something. All right? I don't know if you guys like these puns. I think some of you do. I think this one's going to be amazing. It's a maze. I told you it was going to be amazing. There's only a few more video, guys. You don't have to put up with this much longer. Some of you aren't even putting up with it at all because you don't watch my goddamn videos.